Hello, today we are going to work on lesson 4.5 and it's over exponential and logarithm equations. And we are going to start with problems 5, 9, 13, and 17. If you want to open your book there, we're just going to jump right in. Hopefully you've looked through, followed some examples of what we're doing. Our goal is to solve for x. We're solving equations. So x needs to be down what we call on the main floor before we can solve for it. And so to do that, we can use some of our properties that we learned about logarithms and exponentials to do that. So if we take the log of both sides here, then x will come down in front, but we have to take the log of this side as well. And then we can divide both sides. The log of 25 divided by the log of 5. And that is a log. Those are G's. So we can say the log of 25 divided by the log of 5 comes out to be 2. Okay. Okay, let's look at number 9. So number 9 says 4 to the x equals 1/16. And so look at that one correctly. What the heck? Log, that should be 125. That didn't seem correctly. So that should be log of 125 divided by 5 should be 3. X should equal 3. Sorry, that didn't seem right. The next one is 4 to the x equals 1/16. So we're going to kind of think ahead and think of what x, when I raise 4 to it, is going to give me a number that's in the denominator. So we could do some guess and checking, like we could have over here. You might already know that 5 to the third gives you 125. But in number 9, let's say if we take the log of both sides again, and then divide again. So the log of 1/16 divided by the log of 4, we will see that we get x is a -2. So we can do the log of 1/16 divided by the log of 2. No, that was a log of 4 times 2. So that's a -2. Okay, so on 13, so 13, we need to isolate this 1.3 to the x first. So we're going to divide by 3. So 1.3 to the x equals 5/3. And we can leave it as a fraction for now until we do all of our other items. So by taking the log of both sides, and then dividing both sides, we get the log of 5/3 divided by the log of 1.3. So the log of 5/3 divided by the log of 1.3 is 1.947. Okay, let's look at number 17. So 17, we need to take the log of both sides to get our x's down. So we'll have a negative, I'm going to put in parentheses, negative 2x minus 1 times the log of 3 equals x times the log of 2. And I'm going to distribute, let's see here. Let's see what we want to do. Let's go ahead and divide both sides by the log of 3. So we get a negative 2x minus 1 equals x times the log of 2 over the log of 3. And that is an actual value. So we can find that log of 2 divided by log of 3. Okay, so this will be a negative 2x minus 1 equals x times 0.6309. So we're going to get our x's over to the right hand side. By adding 2x. So we have negative 1 equals 0.6309x plus 2x. So a negative 1 equals 2.6309x. And to solve for x, we're going to divide by that. So we're going to say a negative 1 divided by 2.6309. And we get a negative 0.38. A negative 0.38009. So we'll just say it's a negative 0.380 because there's nothing to necessarily round that to. 21 and 25. So these have the natural number e in them. So we're going to have to use the natural log for these. And these in purple just to kind of separate them out. Okay, so we need to isolate this piece right here. So we're going to subtract 7 and divide by 5. So we get e to the x equals 5. And then if we take the natural log of both sides, those cancel and we get x equals the natural log of 5. And if you put in the natural log of 5, so you should have a natural log button on your phone, or I mean on your calculator, natural log. Right there it is. Natural log is kitty corner from the 4. And then just put in 5. You should get 1.609. It's approximation. Okay. So 25, again, we have to isolate the e. So we're going to add 2 to both sides. So we'll get e to the x squared plus 1 equals 5. And then take the natural log of both sides. So when we do that, and we take the natural log right here of both sides, that cancels out. And so we're left with x squared plus 1 equals the natural log of 5. Now, we could, that's just an x, not a negative x. So we could go ahead and solve for x. So x squared equals natural log of 5 minus 1. And then we're going to take the square root of that. So because the natural log of 5 is going to be an irrational number, if you can wait to do the square root until you get there, it gives you a more accurate. So it's going to be an approximated number. And it will be the square root of the natural log of 5 parentheses subtracting 1, which is, oops, sorry, I think I could see that natural square root of natural log of 5 subtracting 1.7807. 0.7807, and it's plus and minus. And square root of that plus and minus. Okay. Lots to do here for practice, lots of practice. So 33 says the natural log of x minus 1 equals 2. So the natural log, so to do this, we need to now we're kind of going from natural log to base e, or to a base 10, whatever our base is. So this is natural log, so this is going to be e. So this is really e squared equals x minus 1. That is when we're translating from natural log to exponential. Okay, and then we'll evaluate the e squared in a minute, but to solve for x, we're going to add 1 to both sides. So it's really e squared plus 1 equals x. And we can do that in our calculator. We can say the natural number e is the second in your natural log key. So natural log e squared down and then do plus 1. And we get approximately 8.389. That's approximation 8.389. Okay, 37. So we have base 3. So this is really 3 squared equals x plus 4. That's 9 equals x plus 4. Subtracting 4, we get x equal to 5. We like those. Those are fun. Let's look at 41. So 41, we have 2 logs being added. So that means we want to combine them first. And that means if we combine them, they're a product. So it's really the log of x times x plus 3 when we combine them equals 1. And so this is log of x squared plus 3x equals 1. And then we're going to turn this into a base 10. So this is 10 to the 1 equals x squared plus 3x. And 10 to the 1 is just 10. So we could set this equal to 0. So this is x squared plus 3x minus 10. And then we're back to like what we did earlier in the semester, factoring. So we can say x, what we've got, x plus 5 and x minus 2. So x equals a negative 5 or x equals a positive 2. Yay. Okay, we have another one here in 45. So 45 is a natural log. We need to get them on the same side here. So I'm going to bring this one over here. So this is going to be the natural log of 2x minus the natural log of x plus 3 equals 1. And a subtraction means it's really the quotient. So it's the natural log of 2x over x plus 3 equals 1. And then we're going to rewrite this as e to the 1 because it's a natural log. So it's e to the 1 equals 2x over x plus 3 And then we're going to have to do some more solving here. So E is an approximated number. So if I multiply both sides by x plus 3, I've got E times x plus 3 equals 2x. So we've got E times x plus 3E plus 2x. E is just that natural number, so we could just multiply, get 3, we could just, so 3 times E, oh, I wanted that, 3 times E to the 1, it's just 8.14, so this is 2.718. I wanted, oops, I thought everybody could see this. So 3e to the 1 is 8.15, and then e to the 1 is 2.718. So this is just 2.718x plus 8.155 plus 2x, oops, equals 2x. That should be equals. Okay, so 8.155, if we subtract 2.718 from both sides, we get a negative 0.718x. And then we divide 8.155 divided by 0.718 negative. We get is there a solution here? This is going to come out to be a negative number, a negative 11 point, but we can't take the natural log of a negative number. So this is not going to be a solution. We have to check that. So here we could have for 41, I didn't think about that either. The negative 5 we can't take the log of a negative, so that one can't work. But we can do this one, so that one's okay. So we just have to go back and just check those. I just dawned on me. And so this one is going to be a no solution because it comes out to be negative on 45. Okay, 49. A whole slew of these that I went over today. So 49, we're combining our logarithm properties here. And so this is going to be a product of 2x plus 5 times x plus 1 equals 1. And so this is going to be 10 to the 1 equals the product of this. So 2x squared plus 5x plus 2x plus 5. So when we combine like terms, let's bring that to the other side. So we have 2x squared plus 7x minus 5. And then will that, I don't know that that factors, so, and I can't do that quick enough. So let's do our quadratic formula. So x equals a negative b plus or minus the square root of squared minus 4ac all over 2a. So a negative 7 plus or minus the square root of 49 plus 40 over 4. So a negative 7 plus or minus the square root of 89 over 4. So it just can't be the negative of that. The positive value can work, but just not the negative. Okay. The last few that I want to go over, 57, 61, and 65 are all monetary problems, I believe. So 57. Oh, nope, I've got a bacteria one too. But so 57 is asking us, it says how long it takes to determine how long it takes to double the given investment if R is the interest rate and the interest is compounded continuously. Assume that no withdrawals or further deposits are made. So our initial amount in 57 is 1,500 and our rate is 6%. So how long will it take to double? So we need to go back to some formulas that we learned about compound interest. And that was compound interest is the future value is the principal times the e to the rate times time. And we know that we want our money to double. So when it's going to double, then double means that our proportion of A over P is 2. Whatever our principal is, we're going to double it. So we could say we want to double it to 3,000. And then our rate is 0.06, and we're trying to find the time. But we know then when we trying to isolate E, 3,000 divided by 1,500 is where we get the 2. So that's where the doubling comes into play. And then we get E to the 0.06t. And then if we take the natural log of both sides, the E goes away, and then we can divide by 0.06. So the natural log of 2 divided by 0.06 equals, so the natural log of 2 divided by 0.06. Oops, I can show you all that. Natural log of 2 divided by 0.06 is about 12 years, 11.55 years. So 61 is asking us to do the same thing. And it's because it's a doubling, we can skip to the 2. So we know that we're doubling, and it's going to be E to the 0.075t. So again, take the natural log and divide by 0.075. And we get the natural log of 2 divided by 0.075. And we get approximately 9.24 years to double. Okay. 65 is the next one I would like to do. So 65 says we have an initial amount, 4,000. it says, find the interest rate R if the interest is compounded continuously and no withdrawals or further deposits are made. So we're using the same formula we were. So A equals P e to the RT. And our initial amount in 65 is 4,000. We don't know the rate. And it says the amount in 8 years. So it's been 8 years is now 6,000. Okay, so divide by 4,000. Is 3/2, so 1.5. So e to the 8 times r, basically. So we take the natural log of both sides and divide by 8. So the natural log of 1.5 divided by 8 equals r. So the natural log of 1.5 divided by 8 is 0.05068, 0.05068. So the rate is 5.068%. Cool. Number 69 is the last one that I wanted to do. And this one is a bacteria one. So it says, suppose a colony of bacteria doubles in 12 hours from an initial population of 1 million. Find the growth constant K if the population is modeled by the function P sub 0 e to the KT. When will the population reach 4 million or 8 million? 4 million or 8 million. Okay, so we're using this formula here. Okay. Now it says it doubles in 20 hours. So the initial population P0 was 1 million. E to the K, and they said that was in 12 hours. And it doubles, so it's going to be 2 million. So again, this doubling thing, because when we divide by 1 million, we get 2 equals e to the K 12. And if we take the natural log of both sides, we 12 times K. I have to put my coefficient out in the front. So the natural log of 2 divided by 12 equals K. So our natural log of 12 divided by, natural log of 2 divided by 12 is about 0.0577. So our constant of variation is 0.0578. Our growth constant. Okay. So, they want us to that now that we found that, they want us to find out when will it reach 4 million or 8 million. Okay. So 4 million E and our K is 0.0578 times T. We got to find out how long it's taking. That's what we're solving for in this one. So we're 4 timesing in this, right? Divided by 1,000,000 will be 4 equals E to the 0.0578 T. So we're going to take the natural log of both sides, 0.0578 T, and divide by 0.0578. So time to quadruple, that'd be 4, right? So natural log of 4 divided by 0.0578 would be about 23.98. This would be months because it was in months, or hours, I mean hours, so hours. So about a 24-hour period. And so if we want to find for 8 million, it would be 8 times. So this would be the natural log of 8 divided by 0.0578 T. So let's just look at that one. The natural log of 8 divided by 0.0578 is about 35.98 hours. Woo, that wraps up lesson 4.5. That was long. Catch me back for lesson 4.6. We're going to wrap up exponentials and logarithms in 4.6 with some modeling. It's a pretty light lesson.